Hey, this is just a video explaining horizontal asymptotes of rational functions. So I split it into three categories, and it just depends on the degree of the numerator and the denominator, what your asymptote is going to be. So let's start with if you have a higher degree in the denominator. So you can see in this example, it's a degree 1 in the denominator, and there is no x in the numerator. And then you can see in this second example, it's a degree 2 in the denominator and a degree 1 in the numerator. So there's a higher degree in the denominator. So what happens here is horizontal asymptotes are when you look at like the kind of like what happens as x goes towards infinity, or what happens as x goes towards negative infinity. So we're kind of looking at the extremes on the x-axis, like what is happening on either side. Is our graph going to look like this and it's getting close to 0, or what is it going to look like? So if you just pictured subbing in 1,000,000, or pick a big number, if you ended up with 1 divided by 1,000,000 plus 1, so 1,000,001, that number is going to be pretty close to 0. When you have like some number divided by some really big number, you're approaching 0. So in these two cases, our horizontal asymptote is going to occur when y equals 0. So right along our x-axis, that's where our horizontal asymptote is going to occur. Because that's what happens. Like as the graph gets closer and closer to negative infinity, it's going to get close. Y is going to get closer and closer to 0. Okay, so that always occurs in these cases when the degree is higher in the denominator. If you have the same degree, moving on to the next one, so this is both degree 1, numerator, denominator, both degree 1. If you have the same degree in the numerator and the denominator, let's picture it. So you know how I said let's sub in some really big numbers for x? So starting with the first one, let's say we subbed in 1 billion. So the numerator would become 2 billion plus 1, so 2 billion and 1, which is pretty close to just saying 2 billion. Divided by the bottom one, which would just be 1 billion minus 1, which is pretty close to 1 billion. So if you had 2 billion minus 1, or divided by 1 billion, you'd have 2. So we can say for this question, the horizontal asymptote is going to be 2. And the next question, if you were to have like 3 billion divided by 6 billion, pretty much you'd end up with like 3 over 6, which is just like a half. So our horizontal asymptote would just be 3 over 6, or 1/2. So if you have the same degree in your numerator and your denominator, your horizontal asymptote is always just a ratio of your leading coefficients. So that coefficient right in front of x, it's always just going to be a ratio of those things. So 3 over 6, 2 over 1, that's going to be your horizontal asymptote if it's the same degree. Okay, in our last case, if you end up having a higher degree in the numerator this time, okay, in these cases, they're kind of weird. They actually don't have horizontal asymptotes. They actually have something called an oblique asymptote, or it's sometimes called a slant asymptote. So it's not horizontal, it's actually going to be on a slant. So if you have a higher degree in the numerator, in fact, it has to be specifically 1 degree higher. So you can see that the numerators are quadratics, so like degree 2, and the denominators are degree 1. So they are going to have an oblique asymptote. And how you find this asymptote is you actually need to divide the top by the bottom. So you actually need to do some long division or synthetic division in order to figure out what the asymptote would be. So if I try this first one here, and I just quickly divide it, let's do that. This actually becomes our asymptote. So for this question, we would have an oblique asymptote at y equals x plus 5. So literally at the line y equals x plus 5, there would be an asymptote. So instead of just being a horizontal line, it'd actually be on a slant. So that's the final asymptote that we'll look at. Mostly we'll just be looking at the top two. And there you go, horizontal asymptotes.